Hello everyone, my name is Jovison and this is my partner, Eugene Emmanuelle H as a representative from Binus University of Computer Science. Today we're going to present about our paper, which is Machine Learning to Diagnose Disease. This is us as the student from Binus University and our lecturers, special thanks to them, Muhamad Fajar and Puti Andam. For the contents of today's presentation, we have 5 different points, which is the introduction, related work, methodology, results and discussion, and finally the conclusion of the paper. Okay, now first, my friend can start with the introduction of the paper.
Okay, everyone. So first of all, for the introduction, for our project, diabetes is among the most prevalent chronic disease in the world, according to the World Health Organization. About 422 million people worldwide have diabetes, of which majority live in low or middle income countries. 1.5 million deaths are caused by diabetes each year, and both number of cases and death has only been increasing over the past few decades. Detecting early symptoms of diabetes can be challenging due to the ambiguous and subtle nature of symptoms. This research aims to compare the effectiveness of different machine learning algorithms in predicting diabetes, including but not limited to logistic regression, k-neighbors classifier, random forest, and much more. Okay, so next we are going to the related work of the paper. So first of all, there is a hybrid learning model for COVID-19 detection from chest X-rays. The authors itself consists of M. Abdullah, Abra Afsumberhe, Bashir Kadir, Tamrat Tajis Takare. For the next paper, we have machine learning algorithms in screening for type 2 diabetes mellitus. The authors itself is Hani Karman et al. The next paper is diabetes disease prediction using machine learning algorithms. For the authors itself is A.C. Lindow, and A. Choudhury, and S. Moulik. Okay, for the next paper, there is also a detection of disease using machine learning image recognition technology and artificial intelligence. The authors itself consists of Jian Huang, Jing Li, Zheming Li, Zhu Zhu, Chenshen Guoqingqi, and also Gong Yu. Next paper, which is diabetes prediction using machine learning analytics. The authors itself consists of S. Rashmi, Saraj K.R. Biswas, Arpita Nat Borov, Dalton Meite Tonujam, and also Biswajit Purkayastha. For the next paper, which is diabetes mellitus disease prediction using machine learning classifiers and techniques using the concept of data augmentation and sampling. The authors itself consists of B. Shamrin Ahmed, M. S. Arya, Auxilia, Osfin Nancy. And for the last two paper, which is prediction of diabetes disease using machine learning model, the authors itself is A. Sharma, Halpna Guleria, and N. Goyal. For the last paper, which is prediction of diabetes using machine learning algorithms, the authors is Kushi Sidana. Next on, we move forward to the methodology which we use. So, first of all, we use the research question. Mainly, what are the factors associated with the risk of a disease? That is our purpose in the research. So we question it. And then we continue to the dataset selection, which is diabetes underscore binary underscore health indicators, WRFS as 2015. So we use this dataset because it is chosen due to its relevance to the subject and its predictor variables. Next, to the data preprocessing, handling missing values through data deletion or replacement, encoding categorical variables into numeric, and scaling the data when appropriate. Next, which is EDA. The EDA is done through statistical calculation, data visualization, and also correlation analysis. Also next, which is model building. Multiple machine learning models are trained and tested over the same dataset to compare each of the effectiveness. Then finally we assemble model which is created based on the result. For the next methodology will be explained by my partner, Christopher Jovison.
Okay, thank you, Eugene, for the explanation. Now we move on to the next part of the methodology, which is interpretation and conclusion. So in this part, we get conclusion from the explanatory data analysis that includes both correlation and calculation, then is taken and assessed to determine the strengths and direction of correlation, its significance and limitations that might exist. After that, we go to the reporting and visualization, where the results are then summarized and reported to analyze findings, like insights. Okay, these are the model used. In total, we use 5 models, which are logistic regression, random forest classifier, K-neighbors classifier, XGBoost, and knife Bayes. Next, we can move on to the evaluation metrics. In this study, we choose 2 different evaluation metrics, which are accuracy and F1 score. Accuracy itself refers to the percentage of data that the models classify correctly, and it can be shown by this formula. An F1 score is a metric that combines both recall and precision to its own value, which can be shown in this formula below. And for the results and discussion, the first one, from all 5 base algorithms, we found that random forest classifier and XGBoost has the highest accuracy of 0.82, followed by logistics regression on 0.78, then KNC on 0.77, and lastly knife Bayes on 0.74. And from these algorithms through F1 score, XGBoost have the highest on 0.83, followed by random forest classifier on 0.82, and then logistic regression and XGBoost by 0.8, and last but not least, knife Bayes on 0.77. And next, after we train the base algorithm, next we do hyperparameter tuning for the best algorithm. In this case, it's XGBoost, and we have found that it increased its accuracy by 0.3 from 0.2, from 0.82 to 0.85, and the F1 score to 0.84. We also tried 2 different ensemble learning techniques here, which are voting and stacking with multi-level perceptron, which yielded the highest accuracy of 0.87 and F1 score of 0.84, while voting itself has an accuracy of 0.86 and 0.84. Okay, finally, the conclusion for this research is that 1, overall, this research highlights the use of various machine learning algorithms in early disease detection. It consists of data preprocessing, creating the model, and evaluating based on the performance observed. In our case, XGBoost shows the highest performance among all models. Next, for the XGBoost itself, its performance of 0.82 and accuracy of 0.83, and F1 score of 0.83, and it's based, and a 0.85 accuracy and 0.84 F1 score with hyperparameter tuning can be attributed to its own versatility and robustness in handling complex prediction tasks across various domains. Also, using SMOTE might also take part in the shown result. Okay, finally, we explored a bit on the use of stacking with voting classifier, and it has resulted in an increase of predictive ability of models by 4%. Other than voting, we also experimented with the use of artificial neural network as a meta learner, and it will be explored more since it shows the most promising performance, boasting a 5% increase in overall accuracy. Okay, that is all for our presentation. Thank you.